Elon Musk has just announced the launch of Terafab, which will become the largest chip manufacturing facility in history. But that's not what we should focus on today. Because beyond this massive factory, there's also a colossal production machine, one that has allowed Tesla to eliminate thousands of welding robots from its assembly lines. Okay, what if a car was no longer assembled, but instead cast in just a few seconds, like a toy coming off a high-speed production line? It sounds like science fiction, but that's exactly what Elon Musk has done with the Cybercab. They now have a 50,000-ton Giga Press, a gigantic machine capable of replacing almost the entire traditional welding and assembly line at Tesla. And if this becomes reality, the question is no longer how fast can Tesla produce cars, but rather will the auto industry as we know it even continue to exist? While BYD has surpassed Tesla in total vehicle sales, the real battle lies in how cars are made. For more than 100 years, the auto industry has remained loyal to a model that has barely changed hundreds of metal parts stamped separately and then welded together into a complete structure, a process that is time-consuming, costly, and full of potential weak points. That's exactly where Tesla saw an opportunity to rewrite the rules. Starting with the 6,000-ton Giga Press for the Model Y, then 9,000 tons for the Cybertruck, and now the ambition of 50,000 tons.
Like real fast. And then I guess maybe we need to just get even bigger casting machines? Sure, why not? Let's 50,000 tons.
But what is driving Tesla to keep scaling up these machines? And what mechanism allows such a massive piece of equipment to cast an entire vehicle frame in just seconds while still maintaining near-perfect precision? Yeah, the answer lies in how the Giga Press actually operates. To understand why Tesla dares to envision a 50,000-ton machine, you need to rethink the entire car manufacturing process in a completely different way, no longer assembling, but forming the structure from the very beginning. So what makes this massive machine so special? And why does Elon Musk need it at its core? The machine works in an almost insane way. Everything starts with aluminum alloy, the key material in Tesla's design. This metal is fed into a furnace and heated to around 850 degrees Celsius until it turns into a glowing stream of liquid. But this isn't just simple melting. Tesla uses a dual furnace system, a gas-powered furnace for initial heating, and an electric furnace to maintain a stable temperature between 750 and 850 degrees Celsius. Why go through all that complexity just to melt aluminum? You might not realize it, but even a tiny deviation in temperature can create air bubbles or structural weak points in the metal. That's why Tesla injects nitrogen into the furnace to prevent oxidation, while also using argon gas, degassing systems, and specialized filters to remove microscopic impurities. Almost every potential defect is eliminated right from the very first stage. But the most interesting part comes next. Before the molten metal is injected into the mold, a robot sprays an ultra-thin layer of soybean oil onto the mold's surface, just a few dozen milliliters. It sounds like non-stick coating in cooking, but it's actually a critical factor that allows the finished piece to separate perfectly without any deformation. Next, a vacuum system removes all the air inside the mold. This is a critically important step, because if any air remains, bubbles can get trapped in the metal, weakening the entire structure. And then comes the most crucial moment. A high-speed piston forces the molten metal into the mold under enormous pressure. The force is so intense that the metal is pushed into every tiny corner of the mold, leaving no empty space. But this is also where a major challenge arises if the injection is too fast. Air can get trapped. If it's too slow, the metal will cool before fully filling the mold. So how did Tesla solve this problem? The answer lies in the perfect synchronization of speed, pressure, and temperature. Everything is calculated down to the millisecond. This isn't just mechanical engineering. It's a fusion of materials science, automation, and highly sophisticated control algorithms. As soon as the mold is filled, the cooling system kicks in, and this is one of the biggest secrets. The metal, still glowing at around 400 degrees Celsius, is rapidly cooled down to roughly 50 degrees Celsius. This thermal shock doesn't just cool it, it locks in the molecular structure, eliminates defects, and creates an extremely strong and stable metal block. After that, robots quickly open the mold, remove the part, trim off excess material, and move it on to inspection. Each component is scanned using X-rays to ensure there are no internal cracks or air pockets. The entire process is almost fully automated. What's astonishing is that each cycle takes only a few seconds. Think about it, while a traditional production line requires hundreds of robots and multiple stages to complete a section of a car frame, the Giga Press can do it in the time it takes you to blink a few times. And this is exactly why Elon Musk isn't stopping at 6,000 or 9,000 tons. By scaling up to 50,000 tons. Tesla isn't just increasing production speed, it's unlocking the ability to cast multiple parts of a vehicle at once, even moving toward producing nearly the entire car frame in a single press. But here's the catch. If you think a bigger machine simply means faster production, you're missing the most important part of Tesla's strategy. This isn't just about speed, it's about rewriting the entire architecture of the manufacturing process. Now imagine a traditional car factory, robotic arms welding non-stop, sparks flying everywhere, small pieces of metal being joined together into a larger structure through hundreds of steps. This process isn't just time-consuming, it also creates countless joints, and every joint is a potential risk in terms of durability, misalignment, and cost. Now compare that to the Giga Press. Instead of hundreds of welds, you get a single solid piece of metal, no joints, no accumulated tolerances, and almost no need for manual intervention. This is why Tesla can reduce vehicle weight by up to 25% while simultaneously increasing structural rigidity, something that's extremely difficult to achieve with traditional methods. But that's still not the whole story. When Elon Musk talks about a 50,000-ton machine, he's not just referring to a single piece of equipment. He's describing an entirely new manufacturing system called the unboxed process. For those unfamiliar with the unboxed process, instead of moving a car through stations step by step like a traditional assembly line, Tesla breaks the car into large modules: the front section, the middle section which houses the battery, and the rear section. These modules are produced in parallel, not sequentially, and the Giga Press sits at the center of this system, where large sections are formed extremely quickly before being brought together. This leads to a massive shift. The production line becomes so fast that humans can barely keep up. Elon Musk has even said the new system will resemble a high-speed electronics manufacturing facility more than a traditional car factory. So just how fast is it? The answer might surprise you. Each casting cycle takes only about 5 seconds. That means a large portion of a car's frame can be created almost instantly. And in the future, Tesla is even aiming to produce an entire vehicle in an incredibly short amount of time. If this sounds unrealistic, remember that Tesla already shocked the entire industry with the Model Y, when they reduced the number of components and ramped up production speed far beyond competitors. And now, they're doing it again, but on a much larger scale. According to early disclosures, the 50,000-ton Giga Press could cast multiple sections of a car's frame at once, up to 5 major structures in a single cycle. This doesn't just boost output, it dramatically lowers the cost per vehicle. But along with that comes a series of big questions. What would such a massive machine actually look like? How would it be installed? And is it even feasible to operate something like this inside a factory? Estimates suggest that a 50,000-ton Giga Press could be several times larger than the 9,000-ton version used for the Tesla Cybertruck. Its size might rival a house, about 65 feet long, up to 49 feet tall, and more than 32 feet wide. Installing a machine of this scale is no simple task. It would need to be transported and assembled piece by piece, potentially taking close to a year to complete. Even smaller machines, like the 16,000-ton Giga Press systems used by other manufacturers, have taken months to install. But here's the real question. Why is Tesla willing to invest such enormous time and cost into this? Yeah, the answer lies in long-term vision. When you can cast nearly the entire vehicle frame in a single shot, you're not just saving time, you're eliminating entire stages of production, reducing the number of robots, shrinking factory space, and even cutting maintenance costs. In other words, this isn't just a machine, it's a blueprint for building the factory of the future. And if everything goes according to plan, Tesla could produce cars at a speed that once seemed impossible. A car that is no longer assembled, but effectively printed from molten metal. So the next question is, if this technology truly works at scale, what happens to millions of workers and thousands of factories that still rely on traditional welding lines, and will other automakers be able to catch up? Or is it already too late? But the deeper you look, the more you realize that what makes the 50,000-ton Giga Press truly disruptive isn't its size or speed. It's the way it forces the entire industry to change. Because when Tesla shifts from assembly to single-piece casting, they're not just optimizing manufacturing, they're fundamentally redefining how a car is designed from the ground up. So pause for a moment. What happens when a car is no longer made from hundreds of separate parts? Everything becomes simpler, but also fundamentally different. As we know, in traditional design, engineers have to break a structure into many smaller parts to make manufacturing and assembly feasible. But with the Giga Press, Tesla can design large, seamless, and far more optimized structures. This not only reduces the number of components but also eliminates potential weak points at weld joints. The result: a vehicle frame that is stronger, lighter, and more stable. But this leads to a major concern, and you're probably thinking it too. If the frame is a single piece, does that mean the whole car has to be replaced if it's damaged? This is the biggest psychological barrier surrounding gigacasting technology. Many people assume that if one part is damaged, the entire structure becomes irreparable. But in reality, that's not the case at all. Tesla has addressed this with a very smart approach. Instead of casting the entire frame as one single piece, they divide it into three main sections: the front, the center, and the rear. The center section houses the battery, while the front and rear act as crumple zones during a collision. What's unique is that these sections aren't permanently welded together. They're connected using high-strength bolted joints. This means that in the event of a crash, only the damaged section needs to be replaced, rather than the entire frame. You can think of it like a mechanical fuse. In the event of an impact, the easily replaceable part takes the damage first to protect the core structure. This approach not only makes repairs more practical, but also opens up an entirely new direction for the insurance and vehicle maintenance industries. Instead of inspecting hundreds of weld points like before, technicians can now quickly identify damage using sensors and advanced scanning systems. In fact, recent studies suggest that repair times could be reduced by up to 30% thanks to large cast structures. And as you know, time is money, especially in the service industry. But that's still not the biggest shift. When large components are precast with extremely high precision, final assembly becomes faster, easier, and requires almost no adjustments. This allows a repaired vehicle to return to a near original condition, something traditional welding and reshaping methods struggle to achieve. In other words, gigacasting doesn't just change how cars are built, it transforms repair work from a craft into a highly precise industrial process. And when you combine all these factors, production speed, structural strength, repairability, and operating costs, you begin to understand why Elon Musk is willing to bet on such a massive machine. With this new system, Tesla is aiming to produce key parts of a car in just seconds. Yes, not hours, not days, but seconds for the most critical structural components. And this goal isn't just for show. It serves a much bigger strategy: mass-producing an entirely new type of vehicle, the Cybercab. The Cybercab isn't just an electric car, it's a vehicle designed from the ground up for the autonomous era. No steering wheel, no pedals, no complex mechanical components. Everything is simplified to support a future robotaxi ecosystem. This creates a crucial requirement: the cost must be lower than ever before. According to the plan, Tesla wants to bring the price of the Cybercab down to under $30,000. But how can they achieve that when automotive manufacturing costs have always been so high? The answer comes back to the Giga Press. When you reduce the number of components from hundreds down to just a few large sections, you're not only saving materials, you're eliminating an entire chain of costs: labor, time, machinery, factory space, and even the risk of production defects. When you can produce faster, you can sell more. When you sell more, you optimize your supply chain. And when everything is optimized, costs come down. That's how Tesla is trying to turn what once seemed impossible into reality. At Gigafactory, Texas, the first signs are already emerging. Cybercab prototypes are being produced in increasing numbers, showing that Tesla isn't just stopping at the idea stage, they're moving rapidly toward mass production. But let's stay realistic. There are still major challenges ahead. Autonomous driving technology still needs refinement. Regulations haven't fully caught up. And scaling production globally is always an incredibly complex problem. What matters, though, is that Tesla has laid the foundation for an entirely new direction. If they succeed, the automotive industry will never look the same again. Massive factories and kilometer-long welding lines could become a thing of the past. In their place, compact, fast, and far more efficient production systems. And at that point, the question will no longer be will Tesla succeed, but rather, how long will it take other automakers to catch up, or will they remain permanently behind in this revolution? Just a few years ago, the Giga Press was almost an exclusive weapon of Tesla. No automaker believed that casting large, single-piece vehicle structures was feasible at an industrial scale. But by 2026, the situation has completely changed. A wave of major players has entered the race. General Motors, Hyundai, Volvo, and even Speng are now heavily investing in large-scale die-casting technology. So what changed? The answer is simple. Tesla proved it works. When the Model Y launched with a single-piece rear casting, the entire industry took notice. When the Cybertruck adopted a 9,000-ton Giga Press to produce even larger body sections, competitors had no choice but to catch up, and they've started doing exactly that. For example, Xpeng has already deployed a 60,000 tons Giga Press, an impressive figure by traditional standards. But this raises an important question. Does matching machine size mean matching technology? Not necessarily, because the Giga Press isn't just a machine, it's an entire technological ecosystem. You can buy a large casting machine, but can you perfectly synchronize temperature, pressure, materials, speed, and robotics the way Tesla does? Can you control defects at a microscopic level? Can you integrate it into a completely new production architecture like the unboxed process? That's the real challenge, and this is exactly why Elon Musk keeps pushing the limits, from 6,000 to 9,000 tons, and now toward 50,000 ton, not because it's immediately necessary, but because he understands a fundamental rule. If you stop, the rest of the world will catch up. While competitors are still working to implement today's technology, Tesla has already moved on to the next generation, and that gap is incredibly difficult to close. But it's also important to take a realistic view. The fact that many automakers are getting involved in gigacasting isn't a bad thing, on the contrary. It reinforces the idea that this could very well be the future of the automotive industry. Much like how the mass production assembly line transformed the world in the era of Henry Ford, gigacasting may represent the next major leap forward. And as more companies invest, the technology will advance more quickly, costs will come down, and ultimately the biggest beneficiaries will be customers. But let's return to the most important question. If all automakers are heading in the same direction, who will get there first? We believe it will still be Tesla. Elon Musk's ahead-of-his-time vision creates a first-mover advantage, along with real-world experience and deep vertical integration. Tesla isn't just building cars, they're redefining how the entire industry operates. From the 6,000 tons Giga Press to ambitions of 50,000 ton, from traditional welding lines to the unboxed process. It all points toward a future where vehicles are produced faster, cheaper, and smarter than ever before. But what makes this especially compelling is that competitors are accelerating too, and this race is only just beginning. So what do you think? Has Elon Musk truly sparked a revolution that no one can catch up to? Or in just a few years will every automaker have similar technology? Drop your thoughts below. Don't forget to like and subscribe so you won't miss the latest tech insights. And I'll see you in the next video.